In this video, I wanted to look at one other way of defining part regions, and also look at applying using our two-axis operations to go ahead and cut these parts out. To start looking at different ways of defining part regions, particularly I wanted to look at this part that has these mitered edges. And if we look in the simulation, actually I'm going to go back out to the program. I'll try to highlight this with the finishing pass. If we look in our at our profiles or our curve regions, toolpaths here, you can see that the lowest toolpath is not getting to the bottom edge of our miters. And so if we were to cut this part out the same way that we were looking at having like a stepped edge at the bottom of these cones, we would also have a stepped edge all around that miter, which would require us to go back in and clean it up after the fact, after it's cut. If we want to machine all the way down to the bottom edge of this miter, there's another way that we can select the curve, the regions for this cut. And to do that, I'm just going to select my horizontal finishing and do a Control-C and Control-V, or a copy and paste. And I'll double click my folder there in our new copy. And so under our control geometry, I'm going to remove all, and I'm going to go over to the tab here for part surfaces. And so in here we can select our surfaces. We also have an option to set whether the tool stays on the surface or goes to the edge of the surface or goes beyond the edge of the surface. And so in this case, I'd want to set this to go past the edge, and that will allow it to get the tool to get all the way down to the bottom here. And so if I go to select surfaces, I could go around and individually select each surface. I also I set each of those mitered surfaces on their own layer so that I can actually right click and go to select objects, and that will give me all those surfaces. And now if I hit enter, it has those surfaces selected, and if I generate, I should see that now my curve is going to go beyond the edge. And so that is now getting all the way to the bottom edge and would give me a nice clean bottom edge on that part. Okay, the next thing I wanted to look at would be just doing one last two-axis operation to cut these parts out. So you can see that some of these geometries are just floating up above zero. Some of them go all the way down to the ground plane. But either way, to finally go through and cut these parts out, I would go through and select these perimeter regions and just go up and do a 2-axis profiling. And this will be somewhat of a review of the 2-axis tutorials. But I would go back to my 1/2-inch flat tool, load feeds and speeds from the tool. My clearance plane is still okay. Under my cut parameters, I have closed curves, and I want to cut on the outside of those parts. Now we're in 2-axis, so it doesn't care about our 3-dimensional geometry. It's not analyzing that. So we have to set our cut depths. So we're going to say the top of our material is at 2 inches. We want to cut 2 plus a little bit more to get a clean bottom edge. We're going to cut the radius deep at a time. So I have a 1/2-inch tool. I'm going to cut down a 1/4 inch at a time. And under entry exit, we want to choose a long path for our entry motion and change the height to 0.25 to match our cut level, and then say none for exit, and apply the entry exit to each part. We could, under advanced cut parameters, these parts I've laid out to be about 6 inches by 6 inches. With extruded polystyrene foam, they may actually stay in place with the vacuum, but again, it can be foam is also easy to cut, so if we leave a tab to prevent these things from moving as they get cut out, it's pretty easy to go back and clean that tab up. The tabs for foam generally need to be bigger because foam is not as strong as wood. So I might do something like a 1/4 inch high by a 1/2 inch long tab, and anywhere from 2 to 4 of those tabs for parts like this. So I'll leave it at 2. And if we I'm not going to worry about the corners or sorting. We'll just click generate, and we should see our profile cuts and our tab geometries on the bottom. And now if we go back to our simulation, and I'm gonna actually just simulate. Hopefully this will incorporate all the other simulations. So now you can see our parts are cut out, and we have tabs on the bottom to hold our part in place. And there's even a little bit of a tab left here, even though we and a tiny little bit of a lip down here, even though we added in the additional finishing pass. Actually, that might not have been simulated, so let's try to simulate that one and see if that clears it up. Yeah, so that's now going all the way through. So if we go back to our profiling, well, I think we're going to have to simulate it all the way through. So this may take just a second, but then we'll see whether or not if our part is cut totally free when we do the finishing. We may either need to take that risk and hope the part doesn't move as it does the last finishing pass, or we could potentially try to change some other parts of our program. But let's look at what result we get, and I'll talk about some of the ways that we could address the situation. Yeah, so now we can see that actually our part was already cut out after that horizontal finishing pass. But all our other parts look pretty good. And so we've gotten a pretty good definition of those things. We could change some of the tool diameters to try to clean up this more if we wanted to. Like I mentioned, for this part, I would probably remove, so I double click the profiling, the very last profiling operation. We could find that part geometry and delete it. And that way we're not coming in and trying to cut around this part after it's already been cut out. That would be one way to sort of just let the horizontal finishing be the last pass and cut it out, and hopefully it doesn't move. The other thing we could do is, if I double click the horizontal finishing operation, I could try to, if I go into cut levels, I could set a bottom level, and that would essentially require me to still have some amount of material to clean up, and then I would want, in that case, I'd want to come back and do an additional profiling pass around this with the tabs. So that's just a couple ways starting to get into how we might deal with some of the conditions in our geometry and with our program. It's always going to be a balance of sort of how much work we have the machine do and what sort of work we're left to do once we get the parts off the machine. But it's important to realize that you're always going to have some amount of work that you'll need to do by hand to post-process your parts and to clean them up. We have our simulation done. So if I look at that simulation, sort of lost the graphic here. There we go. But just like with the 2-axis file that we looked at, once again, if you wanted to, or if you need to export the simulation STL, you can go up to Simulate, Stock, and export stock as STL, and go ahead and save that file wherever you'd like, and you can have that to use later. That's it for now. Thank you.